Welcome back, everybody. So let me give you a few hints about the exam. So first, what is the material? Well, all the slides, the recordings, the textbook. By the way, I added a reference for the data cubes on the big data textbook because one of the chapters is actually basically a summary of the lecture that I gave last week. So you can also look at this one. I added it to the course page. It's really the same thing as what I did in the lecture. Then you have the theoretical exercises prepared by the team, the practical exercises, especially SQL, and then the clicker questions, even though, of course, the clicker questions are also meant to make you think and might be less precise than exam questions. Obviously, the quizzes are also good to rehearse. The exam itself is going to be computer-based. It's not an exam, you know, there's BYOD, bring your own device, exam on your laptop. It's not like that. Here, it's really a computer that is by ETH. It's a desktop computer in a room. We don't know yet if it's going to be in Ehrlichon or in the Gloriastrasse or in this building, so that we'll know soon the location. But basically, each one of you will be seated on an ETH computer. It will be on Windows. And on that computer, you will have PostgreSQL installed and pre-populated with data. I think it's airlines data, if I'm correct. We'll give you the data before the exam. It will not be a surprise on exam day. You'll have it before. And so you'll have this PostgreSQL installed. You'll have Jupyter notebooks also pre-installed, ready to work. You just click on an icon, it opens. You'll have a few queries that are already in there to get you started. And then you can use this Jupyter notebook to answer questions. So again, to reassure you, there is no Docker, nothing to install. You just come, it's already installed. It already works, right? So nothing for that you have to do. The exam itself is going to be in a Moodle, so similar to the Moodle quizzes for the environment. You will have at most 60 questions. There's a hard cap on the number of questions. The duration of the exam is supposed to be more than you need so that you can really take your time. The goal is that you're not too much under time pressure. Usually, many students leave before the end. So this is really the goal. But if you want to stay and double check your answers, you can, of course, stay until the end. What else can I tell you? So yes, for the query questions, it's typically an assignment in English. Like we ask you a question like, what is the total number of flights that were delayed by more than 2 minutes, like these sort of things. And we ask you for the results of the query, a specific number, a specific string. And we also ask you for the query that you used. The only thing we grade is the result. That's the answer to the question, the integer, the string, and so on. The query is not graded, but it helps us when we investigate, if we accept more answers and so on, it helps us to understand what your reasoning is. So it is useful to us, and it helps us accept more answers. It also helps us, if anybody disagrees, then we have the trace of the query that they've been using. So it's in your own interest, basically, that you also put the query in there, even though it's ungraded. So yes, for the answer, we kindly ask you to format it in a specific way. For example, we'll tell you with or without quotes and so on. So try to really stick to what we tell you in terms of formatting. When we grade, we still try to be a bit lenient. If there's extra spaces and so on, we try as much as we can to accept the answer. So we don't want to punish you for missing a space or that sort of things. But if you still try to stick to what we tell you, you're helping us do the grading. You're helping us making sure that we accept all answers that make sense, basically, because that diminishes the number of answers that we have to accept. So you're increasing the chances that the grading is high quality and fair by adhering to the guidelines we give on the formatting. All right, so I'm telling you that so that you don't stress too much, right? If you have an extra space or something in your answers, we really, really do not want to punish you for that. What else can I say? So yes, there's these queries. Then of course a lot of multiple choice questions on all kinds of topics, and all as a Moodle. What's very important during the exam is when your notebook crashes, for example, because you did a Cartesian product, you can restart it. There will be a few screenshots that show you in the menu, you can just restart the kernel, and that usually solves the problem. If it doesn't, you raise your hand, very important, then a TA will come to you, and then in the worst case, we reset you to a different machine, right? So there's always a solution, but you need to let the TAs know, because if you don't, we cannot know that you were blocked, because when you are blocked, we keep track of the time to give it back to you, right? So if we know you've been blocked for 10 minutes, without doing anything, we'll credit you back the 10 minutes. But for that, you need to raise your hands. You need to make sure that, that the TAs know that you're completely blocked. All right, but still it's better to avoid Cartesian products and that kind of things, because even though we credit the time back, having to move seats and start all over again is still a bit of stress. So it's part of the goal of the course that you avoid crashing the machine, of course. It's part of the, yeah, yes? Oh, most of the questions are going to be purely theoretical questions. The SQL questions are basically one of the sections of the exam. There's in total usually, I don't know the exact number, 8, 9, 10 sections. No promise on the exact number. And one of the sections is the SQL queries, right? So it's just a small part of the exam, the SQL queries. All right. But I still encourage you to work on your SQL skills. It's also useful for later. This is really going to be a language that you might see later, and that is going to come in handy in some of the projects that you have, right? Even libraries like Pandas, Spark, and so on, they give you a way to use SQL as an easier way to query the data. Yep, any other questions on the exam? All right, so I hope it helps. Oh yes, what I can show you, as I will now switch to the Edu app, but also show you the what we just added now. That's the Brave browser. Yeah. So here's what you will find that's new here. There's this past exams section with plenty of past exams as PDFs. It's basically most of them exports from the Moodle for the more recent ones. Some others might not have been on Moodle yet. But basically, you can train yourself with all of these exams. We also put here what you will have on exam day. You will have, this was by popular demand suggested by one of your colleagues a few semesters back. You'll have this cheat sheet available during the exam. And you'll also have some exports of the documentation there. The search will not work because you're not connected to the internet. But if you look at the structure of the documentation and make sure that you know where to find where, then you know you'll have access to a lot of things there. So just so that you know you'll have that on exam day. What is there that I added? Yes, there's this new version of the Docker, which includes the Jupyter notebook that you'll have on exam day and the data that you'll have on exam day. Right? It's all in there. You can re-download that Docker, very similar to the Docker of the course. Just be aware that it's Jupyter Notebook, not Jupyter Lab, because we can only have Jupyter Notebook on the exam machine. So yeah. There is nothing you should bring, just a pen. We'll give you paper. You can just bring a pen, and that's pretty. And your leggy, of course. We need to check who you are. So the pen, the leggy. Learn your password by heart so that you can connect. If you don't know your ETH password by heart, know that today a very good standard for password is 4 random words from a dictionary. You take 4 random words from a dictionary. It's very, very secure. And it's also easier to remember, and most password managers are able to generate a password like that. It's less stressful if you know your password by heart. Otherwise, on exam day, you'll have, okay, can I grab my phone? Can I look in my password safe? It basically creates a bit more hassle, right? We will let you, but it's more complicated. So try to know your password by heart. All right, so yeah, that's it. You can download that zip. It's the Docker Compose command as usual. and that should just work. All right, so let's move on to the quiz. So to make sure that we have time, and then I'll tell you a bit if time permits on big data. So here's how the quiz is going to work. Who knows the game Eisgage 100? 1 against 100. So you know it's all the people at the beginning who play, and then the goal is to answer as many questions correctly, and the longest streak of correct answer designates the winner. So what I'm going to ask you is to all stand. Those who want to play, of course, it's not mandatory, but everybody who wants to play, please stand up. Now, you can do it now. And on Zoom, you can raise your hands to tell us that you are in the game, right? So what I will do is ask you questions that are right there. It will be based on trust, because I don't have a way, we don't have a technical way of checking who answered what. So I'm trusting you. The stakes are also not so high. It's a few sweets, chocolate, and so on. So it's not like it's a million francs for the winner. So I trust you, right? That it all works. And Andreas is playing against you. So the representing the TA team. Do we have anybody else from the TA team? Okay, so it will be Andreas representing the TA team. And so the goal is to see if Andreas survives longer than the best one of you, right? And in the past, often the students win because, of course, you're outnumbered, Andreas. But sometimes the TAs actually do win. So we'll see how it goes today, right? So just so that I make sure, those who are not standing, are you still playing? You can still play, right? You don't have to stand if you don't want to. You're not playing? It's up to you, yeah? Entirely up to you. And are you playing? Okay, yeah. So, and on Zoom, how many people do we have on Zoom? 3, okay. So I'm going to give you a first question. You have to answer it on Clicker. So prepare your phone, your app, the Clicker app, open it and so on. You can also go to the website, of course. And so for Andreas, what I will do, because you need to give an answer at the same time that I press the button. So what you can do is put your answer on a private channel in the Element server, in the TA team. You can go to the TA team channel and give your answer there. So that way you know that Andreas is not just going to read the answer that is correct to you and win every time, right? Okay. Who is ready? Are you ready? Okay. All right. So I'm going to start with hopefully easy ones and then go more and more complex. So which one of the following is not a flavor of the relational model? Sets of maps, stacks of maps, lists of maps, bags of maps. So giving you more time on this one to make sure that everybody is up and running. I still see answers coming in. Everybody enter their answer who wants to play, and on Zoom as well. Please complain if you didn't have time. All right. So now I'm going to do this every time. Have you entered, Andreas, your answer in the TA chat? Oh, wait. I'm going to every time press the button first, and then you can tell me your answer. Okay. So the answer is indeed stacks of maps. That I never mentioned. We have sets, bags, and lists. Bags are like sets, except that you can have duplicates, and lists also have the order that actually matter. All right. So now every time what we will do, and that's also based on trust. If you got one wrong, it's okay. It's not the exam, right? We are just here to play. then you can see it. That basically helps me keep track of who is still running for the trophy. And by the way, even if you get one wrong, you can still continue to answer, right? You're no longer for the trophy, but you can still continue to play with us, right? So do not hesitate to still answer. Okay, the goal is to have fun. Okay, so I'm going to continue. And on Zoom, so instead of sitting, of course, you might be already seated. Actually, you can just lower your hands if you get one wrong. Okay, so let's go to another one. Which of the following holds? A function is always a relation. A partial function is always a function. A relation is always a partial function. A relation is always a function, as we define them in the course, of course. One of them holds. The other three do not hold. Approaching the number of 16. All right. Have you, Andreas, without telling me the answer, entered your answer on the TA team chat? Yes. All right. And then I'm going to click here. What did you enter? A, the first one. Yes, indeed, a function is always a relation. The relation is the most generic you can have between two sets. It's just a subset of all the pairs that you can have, a subset of the Cartesian product. A function has the particularity of associating every item on the left exactly with one item on the right. This is what a function is. Partial function that's 0 or 1, then the relation that could be 2 or 3 associated. So it's the first one. A partial function is not always a function because a partial function might associate 0 items. A function has to be exactly 1. A relation is not always a partial function because a relation could associate an item on the left with 2 or 3. And a relation is not always a function because, again, it could associate with 0 or 2 or 3. Right. All right. So this actually was a question that eliminated a lot of you for the trophy. All right. So who do we have? 1, 2, 3, 4, 5. Anybody not standing, still playing? No, just you, 5. All right. And then on Zoom, how many do we have? One person. So that is 6. Sorry? Oh, Xiaocheng, you're on the chat? Oh, this is wonderful. So you're playing with Andreas. Sorry, I didn't see that. So Xiaocheng, you can, via the element chat, you can communicate with Andreas and agree on an answer. So obviously, Xiaocheng is on the TA side. So on the student side, we have five people. But you can still keep your hand raised, Xiaocheng, because that way we know that you're with us. All right. Well, that was only 2 questions, so I have to pick those that are not too difficult because I don't want to eliminate everybody too early. In which clause does the selection predicate appear in SQL? Is it the where clause, the select clause, the from clause, the group by clause? Where do you put your selection predicates? By the way, even if you've been eliminated for the trophy, you can still play. You can still enter your answer because that's the whole point. That's we all train for the exam. Only 14, not 16? One more? Did somebody fall asleep? Okay, you have 5 seconds to complain if you didn't have enough time. Yes, 16. All right. Have you entered your answer? All right. So what did you enter? A. All right. What you and Xiaozheng, of course. All right. So indeed, it's the where clause. That's a trap. It's not the select clause. In the select clause, you actually have the projection, all the what you project. When you say select from where a specific predicate holds, this is how you do a selection, right? You pick the rows that you want. How many survivors do we have? Only 2? Really? Okay, 2 survivors. So one of you is going to be the winner. Now, here's how it works. It could be that the 2 of you get eliminated in the same question. If that ever happens, you will, both of you come back and stand up again, right? We really need to eliminate you, to eliminate one of you and give the trophy to the winner. It's only a game. All right. Here's another one then. What is a natural join? Is it a join that is spontaneously performed by the database management system without the user having to request it? Beauty of data independence. Is it a join in which the predicate is a conjunction of equalities between attributes? Or is it a join between tables in the Boyce code normal form? Or is it a join in which the predicate is implicitly an equality between attributes that have the same name on both sides? A natural join. Three more. 14, 2 more. One more. We're almost there. Yes, 16. All right. So have you entered your answer? And your answer is D, yes. So you are still in the game, both of you. Very good. Let's continue. Maybe, yes, this one. Is SQL capable of giving you a cross-tabulated view? So slice, dice, and so on. So yes, it is, can cross-tabulate, or no, it can slice, but it cannot dice, or no, it can dice, but it cannot slice, or no, because it cannot be used to roll up, which is a necessary step to slice and dice. By the way, it's still undecided if the TAs win or the students win, right? You're still in the game. Sorry? Oh, you have a disagreement? Ah, and there's only 2 of you. How are you going to resolve it? Did you come to an agreement? More or less? So you have an answer? Okay. So only 15? The 2 of you answered, right? B, yes, exactly. It can slice. A slice is a selection. You use the where clause, right? And dice, it cannot because SQL doesn't know about views. It's not able to present you a cross-tabulated view with all the hierarchies on the columns and so on. I think we have a winner. What is your name? So I didn't get it. Enzo. So big applause for Enzo. Very good. All right. So you can come here, get your trophy. So you have This trophy that was made by Marco Schock with a TA for big data that was done in the student project house, by the way. Apparently they have all this machinery that allow them to do this. So this is your trophy. And plenty of sweets like Twix, Toblerone, also. So they told me that this is the top one. This is the I think Spitzbuber it's called. Yeah. All right. So enjoy it and applause again for Enzo. Now we still have not distinguished between the TAs and the students, right? So since I'm going to give this trophy to the TA team, but we'll still, before you're on it, we'll still see how far you go. We have a second one here for the TAs. So now we'll see if you or Andreas and Xiaocheng survive the longest. But I have to do it in a way that has to actually be difficult. So which of the following are the Armstrong actions? Multiple answers. Reflexivity, augmentation, I should have written transitivity, and composition. Remember that it was in the database design theory when we had the rules to transform the functional dependencies. And we saw that 3 of them are actually enough of the rules. These are called the Armstrong actions. Have you answered? Yes, have you answered? So ABC, ABC. Oh, wow, that was a hard one and you got it right. Okay. Then what characterizes a functional dependency? The domain depends functionally on the attribute name. Some attributes depend stochastically on some other attributes. The dimensions in an OLAP cube must uniquely identify a cell. Given a record picked randomly, if one knows the value of some attribute, then one knows the value of some other attributes. Right? Have you answered, Enzo? Yes? And you too? Okay. D. All right. Congratulations. So indeed, it's like this game of if you know this, then you know that, right? So, all right. How is the data read from disk in a relational database system or management system? In blocks, bit by bit, file by file, table by table. Have you answered? Yes? Have you answered? Waiting, yeah. Okay. A, okay. So, what is the first normal form? The left-hand side of any non-trivial functional dependency must be a super key. All values in the table must be atomic. All tuples must have the same attributes. The functional dependencies must be expressed as a minimal basis. So you have entered it also? Yeah. B also, yeah. Wow, this is really difficult to maybe a harder one. What is the second normal form? A non-prime attribute cannot depend on a strict subset of any candidate key. The left-hand side of a non-trivial functional dependency must be a super key. Values must be in super atomized form, no strings, characters only. Or the table must be a fact table corresponding to a cube. Which one is the second normal form? Entered? Yeah. Also? Yeah. All right. A also? Oh, you said B? Yeah. So B is, so what is B? What kind of normal form is this? Boy's code. Yeah, that's the Boy's code normal form. By the way, the second normal form is not part of the material, right? I just told you it exists. I briefly said what the second and third is, but I needed a difficult question to basically know if the TAs or the students win. So it turns out that it's the TA team who wins this year in the so you win for the trophy and the best students, and the TAs win against the students. So you can have this this trophy for the TA team. All right, we still have a few minutes left, so I'm going to just give a small outlook on big data, just to hope that some of you are going to come back in spring. So first, just to get a general impression, who here has already attended Big Data for Engineers last spring? We have one here. Who has not attending it? Who is considering attending it? Ah, very nice. So I see some of you in spring. So here's what we are going to do there. So this is the menu, right? So for the big data is right this semester, that's for computer science and data science students. And we have this series of 2 courses. These are the good old databases from the 70s, and these are the newer things that popped up in the 2000s. Big data for engineers, next spring. So in big data, we often like to say that there's the 3 V's, volume, variety, and velocity. Volume, because we have to deal with petabytes or even exabytes of data. I think that Google now has exabytes of data officially in Spanner, in their enormous white column store system. Variety, because there's not only tables and cubes, there's also trees, there's also graphs, so we'll focus a lot on trees during this lecture. There's also vector databases and ChatGPT information retrieval. That is for computer science students, so that's the information retrieval lecture also in spring. So variety, all of these shapes, but they all follow data independence still. And velocity, because we have to process that data very fast, so fast that we actually need data centers, because a laptop cannot handle it anymore. And here's why. This here is the oldest commercially available hard drive that I could find. This is from 1956, it's from the IBM Ramac 350. It has an incredible capacity of 5 million characters. That is absolutely enormous, 5 megabytes. It has a throughput of 12,500 characters per second, a latency of 600 milliseconds, and incredible dimensions of 1 meter 50 times 70 centimeters times 1 meter 70. So that is absolutely enormous. So now, of course, we're in 2024, and that actually looks quite inefficient, because this is what we have today. We have the largest that I ever found, which has 26 terabytes in just this shape, right? And so you can see that a lot of things have happened. And what has happened is that in the same cubic centimeters, so the same unit of volume, we can store 23 billion times as many bytes as we could in 1956. So that was basically 70 years, 23 billion. What about the speed at which we can read these bytes? How many characters per second, bytes per second we can read? Only 20,800. Of course, that's a lot, 20,800, but it's nothing compared to the 23 billion. Do you agree that we have a big problem? Because we're storing much, much more data, but we cannot read it fast enough. If you want to read the entire drive, now it's going to take like much, much, much more time. It's going to take thousands of years instead of a million times less, right? So this is an absolutely enormous difference. And the latency, it's even worse. Don't even get me started about that. Just 144. The latency is basically the time it takes to start reading. If you have a mechanical drive, it's you need to wait until it has moved to be under the reading head. just 144. That's an absolute catastrophe. And what that tells us is that everything we've been using so far in terms of computers, hard drives, laptops, and so on, that is totally useless to deal with the data under these conditions. That here is the reason why we need big data. And in big data, we needed to completely reinvent everything in order to solve that problem. And as you might guess, this is solved with data centers. This is solved with parallelism. We're going to throw 1,000 machines on the same problem that are going to read all these disks at the same time. And I also explained how we deal with the latency problem, that it takes relatively, in comparison to the throughput, it takes more time to start reading the data. So big data is basically trying to solve that problem. We have a problem of discrepancy between these three, the capacity, the speed at which we read, and the latency. And big data is a portfolio of technologies that solve exactly that problem. So we will learn how we can handle data on huge data centers with the data distributed all over the place. Examples of application are how to process all the maps of the sky. Now we have plenty of projects. There's Euclid now also. So to map the sky, the quantity of data doesn't fit on your laptop. It's absolutely enormous. And this is one of the examples for which we need these kind of technologies. This is a lecture focusing on databases. I'm not going into machine learning or AI. There's plenty of lectures at ETH for this, so we are focusing on databases. But of course, that connects to machine learning and AI, because the goal of the databases, you can see it as to prepare the data for machine learning and AI, right? To clean it up and prepare all the features so you can learn on them, for example. And also there's people working on the integration of machine learning into the databases. One example being vector databases, and we had a guest lecture on Wednesday in big data by Oracle about their vector database system, and they are using machine learning and LLMs in order to extend the SQL language and the databases. So this is what we'll have. We'll look at S3, which is Amazon's object storage system, where you store, all of the movies you watch on Netflix and the series. It's all stored in there, all shredded into clips over a few seconds and stored in these systems. We'll look at distributed file systems. How do you store a petabyte of data on the same file system? Well, in a data center, you can do that. We'll look at XML and JSON syntax and the models that come with that. White column stores, which are absolutely gigantic relational table. And again, I said Google has tables or systems that have an exabyte of data stored in such column stores. We'll look into the validation of data, because when you clean up data, you want to then validate that it's clean. You will look at who heard of MapReduce? Spark? Doesn't ring a bell for it was a buzzword a while ago. So this is the secret of how we process the data on top of a data center, all in parallel. So MapReduce and Spark, Apache Spark. We'll look at database management systems for trees, and we look at MongoDB as an example. So MongoDB is like PostgreSQL, except that PostgreSQL is for tables, and MongoDB is for trees. And we look at query languages for trees with the example of JSONic. So I hope it gives you a small appetizer for what's to come in the spring. I would like now an enormous applause for the TA team, and in particular, Andreas and Xiaocheng, who are here today. So thank you very much for the great job. So I guess that this is it for the lecture. So next week you can use the time to rest a bit or train on the exam if you want, but there will be no lecture. If you have any questions during your exam preparation until the exam, which is it January 29th or February 4? I have two exams. I swapped the date. It's the 4th of February, this one, yes. So the 4th of February. During this period, if you have questions, write us emails, write on the Element chat, write on the Moodle forum. We'll try to help you. If you ask your questions publicly, it's nice because then everybody can see the answer. So it's a good idea. You can have a discussion. Do not hesitate to also ask your colleagues. You know that the best way to learn is to teach. So if you have the feeling you can explain the material to your students, to your fellow students, then do it. this is a great way to spot any weaknesses, because when you try to explain, you might notice, okay, that I wasn't able to explain, then you look. So again, try to also teach to each other. So we will be here for you, maybe not between Christmas and the New Year, because a lot of us will probably be resting a little bit, but we'll be here to help you, right? So let us know if there is anything that you don't understand. Thank you very much. It was a great semester, great interaction on here or on Zoom. So thank you very much for this. All the best. Take a good rest during the vacations, and I'll see you at the latest on February 4th then for the exam. So thank you very much. Goodbye, everybody, and see you in spring for many of you.